What's going on, everyone? Don here with the Physics Instructional Resource Team. I've got another demonstration for you here today called the torque balance. And what this is going to do is it's going to teach us about the concepts of torque. Now, torque is also called the moment of a force. And it's not like a moment in time, it's more like a moment in space that a force is being applied. And so what we've got here is this rod, this bar, this metal bar, that can rotate around the center here. And we call this the rotational axis. And we can apply a force at different distances by hanging masses from these hooks. We can apply a force at these different distances, and that'll apply some rotational force. And we can change the distances. These equidistant hooks will change the radius by a set amount on either side, and we can change the force by having these mass hangers applying the force of gravity at the moment of the hook. And so if you have two 1 kilogram mass hangers, so the force is equal, and we put them at the same radius, say 3 units from the center, we will see that the torques balance out, and the bar does not have any inclination to rotate around the center. Now, what should happen if I change the radius by 1 unit? It wants to rotate just a little bit, not too fast, but it does want to rotate in that direction because now we've increased the radius from the center of rotation. And it'll go even faster and faster. The momentum will change faster and faster the more I put the radius out. So this is what it looks like when the difference between the radii are kind of small. And if I go all the way out here, it goes really fast. And so we can actually balance these torques by changing the radius. Now we could also adjust the mass and therefore the force of gravity being applied at these points from the center. So if I get another kilogram mass, these weigh 1 kilogram, I'm going to add 1 more kilogram here. We'll see. It does want to rotate on the side where I add the mass. But how can I balance this using what we just learned about moving the force further away from the center? Well, if I multiplied the mass by 2, torque is the product between the radius and the force. And so if I multiply the mass by 2, I should be able to balance it out by increasing the radius by a factor of 2. So 3, 4, 5, 6, twice the radius, and we see it balances out. And we can do the same thing again. If I instead have a factor of 3, I can increase the radius by a factor of 3, so 6, 7, 8, 9, so 3 times 3 is 9. And we see that it does balance out. And when you balance the torques, there's no reason for this bar to rotate. And that's at the center of all rotational forces. Anything that has rotational motion or rotational momentum that's changing has a torque acting on it. And you need to understand this simple situation before you can start tackling more dynamic systems. And so that in a nutshell is torque and the torque balance, and I'll see you next time.